So today we're going to talk about multi-step inequalities. And there's a different format that we can write our answers in, which is what we're going to be focusing on this week. So the format is called interval notation. And it's just another way of expressing the answer to an inequality. It uses parentheses and brackets to show where the graph starts and where it ends. So there's two different symbols that you're going to see with interval notation. You're going to see a parenthesis and you're going to see a bracket. The parentheses, you use it when you're not including something, or when you're graphing, there's an open circle. It's just means that if there's a parenthesis, you don't want to include that number in your answer. Now for a bracket, that means you are including it. And that's when you're going to use a closed circle on your graph. So for the most part, you're going to use parentheses unless you have the less than or equal to or greater than or equal to part in your graph. And then there are some cases when you need to use the infinity sign. It's whenever your graph is going on forever, like x is greater than 1. Well, then you would have, since it's greater than 1, you'd have a parentheses for your 1. And since it's everything including, or not including 1 and bigger, you'd want to use the infinity sign. So you'd use parentheses because you can't really include infinity. It goes on and on forever. So you're pretty much always using parentheses unless you need to use that closed circle. So let's look at some examples. So our first example is 4 times parentheses x plus 3 is greater than negative 24. So step 1 is to solve this, and we are solving like we would normally solve inequalities or normally solve an equation. Now remember, there are different times when you have to flip that inequality sign. Remember, if you are multiplying or dividing by a negative, you need to flip that sign. Okay, so when you multiply or divide by that negative number as your final step, you need to flip that sign. If you're multiplying or dividing by a negative, it's not your final step. You still want to do that. You still want to flip it, but normally that's the last step you do. So just keep that in mind. So for number 1, the first step we do is we distribute. So we're distributing 4 to both the x and the 3. So we have 4x plus 12 is greater than negative 24. Next step is to go ahead and get rid of this plus 12. So we're going to subtract 12 from both sides. And when we do that, we get 4x is greater than negative 36. Now, to get this x to be equal to 1x, we need to divide by 4. Since we're dividing by a positive number, the sign's going to stay the same. So even though this 36 here is a negative 36, you still want to keep the sign the same because we're dividing by the 4. So when we divide by 4, we get x is greater than negative 9. So you should know how to graph an inequality, but just in case you forget, whenever the sign is eating the variable, that means that you are graphing to the right. You're shading to the right. Since this is a greater than sign, we are going to use an open circle, and then it's going to be on negative 9. Okay, so open circle on negative 9, and the sign is eating the variable, so we're shading to the right. Okay, so this is everything that is greater than negative 9. Remember, for negatives, even if it looks smaller, that actually means it's bigger. All right, so interval notation now. This is the part that's a little weird. Since we have a negative 9 here, and that is our smallest part of our graph, that's going to be the first thing on our interval notation. So we're going to start with a negative 9, and we're going to have a parentheses to show that. And then, since this is going on and on and on forever, to the right here, and this over here would be infinity, and over here would be negative infinity, if my lines would connect. So since we're shading towards infinity, we're going to want to include a positive infinity in our interval notation. Okay, so if this was shading to the left, we would have a negative infinity first, and then negative 9. But since we're shading to the right, we have our negative 9, because that's the smallest part of our graph, and it's not included, so it's a parentheses. And then we're shading towards infinity, which would make it infinity as the other part. All right, so example 2. We have x minus 3 times the parentheses, x plus 2 is greater than 4. So step 1 is to distribute our negative 3. Okay, so we want to make sure we're passing out that negative 3 to both parts. Okay, so when we pass out that negative 3 to both parts, we end up with x minus 3x minus 6 is greater than 4. Step 2 is to combine our like terms. So we're going to go ahead and combine our like terms. We've got an x term here and an x term here. And then we have just a constant term here, so that's going to stay the same. So we're doing 1x minus 3x to get negative 2x. Bring down the minus 6 is greater than 4. Now we can go ahead and solve this. We're going to add 6 to both sides to get negative 2x is greater than 10. In this case, we are dividing by that negative, so we need to make sure we're flipping our sign. So we divide by negative 2, we get x is less than negative 5. So then for our graph, we're going to have our open circle because it is a less than sign. Okay, there's no line underneath this, so it's an open circle. We don't want to include negative 5. Open circle on negative 5. And we're going to shade to the left because the sign is not eating that variable. If the sign eats the variable, we shade to the right. So for interval notation, since we have our arrow over here, our smallest part of our graph this time is actually going to be the negative infinity. Okay, because we're pointing towards our negative infinity, not our infinity. If it helps, I would definitely add negative infinity and infinity on your number lines, just to make sure that you're remembering that you need to be including that in your interval notation. So negative infinity, we're shading towards that. So we'll have a negative infinity with our parentheses, comma, the biggest part of our graph is this negative 5. So it'd be parentheses, negative infinity, comma, negative 5, and then also another parentheses because this is an open circle. Okay, so again, we're still using parentheses because we don't have anything that we are including just yet. All right, number 3. We have 7x minus 2 times the parentheses, x minus 4 is less than or equal to negative 2. So we're going to solve this just like we solve our equations. Distribute that negative 2 first to both parts. Then step 2 is to combine our like terms. So we're going to combine our 7x and our negative 2. Step 3 is to get rid of this 8 here. And then we're going to divide by 5. And again, we're dividing by a positive 5, so the sign stays the same. So now we have x is less than or equal to negative 2. Okay, so for our graph, we're going to have a closed circle this time because of the underline. So less than or equal to, that's a closed circle on negative 2. And since it's less than, we want to point to the left. Okay, so again, we are going to add our infinity and our negative infinity. And then for my interval notation, I know that I have negative infinity is the smallest part on my graph because it's shaded towards it. So I'll have my parentheses negative infinity just like I did above. And then I'll have comma negative 2. But since this is a closed circle, we are including it, so I need to use a bracket. Okay, so since it's a closed circle, we're finally using that bracket. Number 4, we're going to go ahead and solve this. So I've got negative 8 times parentheses x minus 1 minus x is less than or equal to negative 28. So step 1, distribute. So I've distributed the negative 8 to both the x and the negative 1. Make sure you're passing that negative out to both parts. So I've got a positive 8 now, minus x is less than or equal to negative 28. Step 2 is to combine our like terms, negative 8x and negative x to get a negative 9x. The next step is to subtract 8 from both sides. And then we're going to divide by negative 9. And since we're dividing by a negative, we're flipping that sign. Okay, so we have x is greater than or equal to 4. So I want you to pause the video. I want you to create the number line, and I want you to write it in interval notation. All right, so if you're pressing play, that means you've tried this problem. So our number line should look like this. We have a closed circle on 4, and we are shaded towards our positive infinity because the sign is eating the variable. Okay, so since it's being eaten, we're going towards infinity. And then when we're writing our interval notation, we'll have our bracket on our 4 because it is a closed circle. And then since we're going towards infinity, that's going to be the second part. All right, so a couple more. Number 5, we've got 6x plus 1 is less than 9 minus 2x. So again, we got variables on both sides, so we're solving it just like we did with multi-step equations. So I'm not going to go through the whole process. But But step 1 is to move our variable. So since I have a negative 2x here, and that's the smaller one, I'm going to move that. So I'm going to move that to the other side. So I have plus 2x to both sides to get 8x plus 1 is less than 9. And then solve as usual, minus 1, divide by 8 to get x is less than 1. Since this was a positive, we don't touch the sign. Now over here, I want you to pause it, create your number line, and create your interval notation. All right, so if you press play, you should have your number line, which would be an open circle on 1, and you are shading to the left because that sign is not eating that variable. Okay, and then your interval notation, you are heading towards a negative infinity over here. So your smallest part of your graph should be negative infinity. And then you are not including 1. So it should be parentheses, negative infinity, comma, 1, also parentheses. Because you are not including it because this is not a greater than or equal to or a less than or equal to sign. All right, number 6. I want you to solve it, and I want you to graph it. So press pause, try the problem. All right, so if you tried the problem, you should have gotten x is greater than or equal to -7. Pause the video, check your work if you did not get that. And then for your interval notation and for your number line, you should have, since it's a greater than or equal to, a closed circle on -7, and it is eating the variable, so it's to the right. And then that means that the smallest part of our graph is the -7, and we're including it because it's a closed circle. So that's why it's a bracket. And then you're shading it towards infinity. So that's why infinity is here. All right, let's try another one. Number 7. Pause it, try it on your own, press play when you're ready. All right, so when you are working on this one, remember this minus here is like distributing a -1 to both parts on the inside here. So you have 3 minus 2x plus 7, because the negative gets passed out to both parts, is less than or equal to 34 minus 6x. And now you can go ahead and I would combine like terms and then move things around. So we combine our like terms to get 3 plus 7 is 10. Now I can go ahead and move my x values. And since this -6 is smaller, I am going to move that one. So 4x plus 10 is less than 34. Solve it as usual. 4x is less than or equal to 24, which gets me x is less than or equal to 6. And then for your number line, it is less than or equal to. So we're going to shade to the right. And we're going to have a closed circle on 6. Oh, I'm sorry, shade to the left because it's not eating the variable. Sorry about that. So then we are going to go ahead and shade to the left because it's not eating the variable, closed circle. And then for our interval notation, this is negative infinity over here. So we have parentheses on negative infinity, comma, 6, and then a bracket because it is a closed circle. All right, number 8. Try number 8, pause it, graph it, interval notation. Press play when you're ready. All right, so for number 8, step 1 is to distribute. So we're distributing that -3 to both the x and the 2. And then you want to combine your like terms. And then you want to go ahead and move your x values. In this case, we're just going to move the 2 over to the left. It doesn't matter which side you pick. So in this case, we subtracted 2x from both sides, add 6 to both sides. We are dividing by a negative here, so that is going to flip my sign. Okay, so I have x is greater than -3. If you moved your variable to the other side, you will still have this. It'll just say -3 is less than x. Same answer, same thing. Easier to read when you flip it like this. So I would try and keep your x values on the left at all times, even if it is making it a negative value. It's easier to read that way. So for our graph, since it is x is greater than -3, we're going to have an open circle on -3. And then we are shading to the right because it is eating the variable. So it's eating the variable to the right, open circle. For your interval notation, it's going to be a parentheses on -3 because it is an open circle. And then you are shading towards infinity. So you want a positive infinity there. And again, if it helps, make sure you're writing your infinity and your negative infinity so you're not confusing the two. All right, number 9. So for number 9, same idea, you have to distribute. So we're going to distribute our -3 to both parts and distribute our -1 here to both parts. So you distribute, and then you can go ahead and combine your like terms. There are like terms on both sides to combine this time. So on the left side, I've got this one, and I've got these x terms. I'm going to use a different color on the other side just so they are not confused. Okay, got those constant terms there, and my x value there. So I can go ahead and combine my like terms. So I've got 5x minus 3x to get 2x, bring down the minus 18, and then I'm doing 8 plus 7 on this side to get 15 minus x. Then you can go ahead and move your x terms again. Easiest to move them to the left, just so your x value, when you solve, is like on the left side. It's easier that way. So I'm going to move my left one to get 3x minus 18 is greater than or equal to 15. Add 18 to both sides. Divide by 3. Since we're dividing by a positive, the sign stays the same. All right, and then we have x is greater than or equal to 11. So for my inequality, I'm going to go ahead, for my graph, I'm going to go ahead and put a closed circle on 11 because it is a equal to one. And I'm going to shade to the right because it is eating the variable. And then for my interval notation, using the graph, I'm going to add my negative infinity and my infinity. So the smallest part on my graph is this 11. So I'm going to put my bracket, because it's closed, on 11. And then the other part is a positive infinity. So I put bracket 11, comma, infinity, parentheses. All right, last one. Try this one on your own. Press pause. Press play when you're ready. So when you solve this one, first you distribute, and then you combine your like terms, and then you can go ahead and move your x values, and then you can move that -3. And then we have a negative x over here, so we are going to divide by -1. Okay, so we're flipping that sign because we're dividing by a -1 here. And that will get me x is less than -9. So since it's x is less than -9, I'm going to go ahead and put an open circle on -9. And this sign is not eating the variable. Okay, so we're going to shade to the left. And then for my interval notation, I've got negative infinity, I've got infinity. The smallest part of my graph is going to be negative infinity because the arrow is pointing towards it. Okay, so it's going to be parentheses negative infinity, comma, -9, that's the biggest part. Also parentheses because that's an open circle.